On July 1st, 25, telescopes from the Asteroid Terrestrial Impact Last Alert System in Chile detected something extraordinary. A 20-kilometer diameter object traversing our solar system at 66 kilometers per second. It's named 3I Atlas, and it's only the third interstellar object ever observed by humanity. But something isn't right. Its characteristics defy every astronomical model we know. It's too bright for an asteroid, too quiet for a comet, and its trajectory seems almost designed. Professor Avi Loeb from Harvard published a scientific paper that asks a provocative question. What if it's neither a rock nor cosmic ice, but something entirely different? Today we'll explore the anomalies of 3I Atlas together and discover why a part of the scientific community is asking some very uncomfortable questions. If you're fascinated by the mysteries of the universe and want to stay updated on the latest developments in astronomy, subscribe to the channel and turn on notifications. Before we delve into the anomalies, let's take a step back. Interstellar objects are extremely rare. The first, Oumuamua, was discovered in 2017 and observed for just 2 months. It also presented some anomalies, and if you want to know more, you can find a dedicated video on my channel. The link is up here. The second, 2I Borisov, was spotted in 2019 and behaved like a typical comet. 3I Atlas therefore represents a tiny but precious statistical sample. The object travels on a retrograde hyperbolic trajectory, which means it moves in the opposite direction to the planets in our solar system. Its velocity at infinity is about 60 kilometers per second, confirming its interstellar origin. But here's where the strangeness begins. The orbit of 3I Atlas is inclined by only 5 degrees relative to the ecliptic plane, the plane on which the planets of the solar system orbit. According to calculations, the probability of such a precise alignment is just 0.2%. The second major anomaly concerns its brightness. When it was discovered, 3I Atlas was 4.5 astronomical units from the Sun. That's 4.5 times the Earth-Sun distance. By analyzing the reflected light, astronomers calculated a diameter of about 20 kilometers. Here's the first statistical problem. As highlighted by Professor Avi Loeb in his article, Is the Interstellar Object 3I Atlas Alien Technology? An interstellar object of this size is extremely rare. Statistically, we should have observed millions of objects the size of Oumuamua before encountering one as large as 3I Atlas. The probability of detecting a 20-kilometer asteroid in the inner solar system over a 5-year period, based on the expected rates of interstellar objects, is about 1 in 10,000. If 3I Atlas is too large to be a typical interstellar asteroid, perhaps it's a comet with a much smaller nucleus surrounded by a large cloud of gas and dust. This explanation would solve the problem of its apparent size. But the spectra obtained so far show no trace of the typical spectral lines of comets. No water, no carbon dioxide, no methane. Only reflected sunlight, slightly reddened like that bouncing off organic surfaces altered by cosmic radiation. Astronomer Cyril Opitum and her team described the spectrum as red and featureless in a recently published paper. It's a chemical silence that doesn't fit either an asteroid or a comet approaching the Sun. Furthermore, 3I Atlas's trajectory has features that have captured the attention of scientists. The object will pass surprisingly close to several planets: Venus, Mars, and Jupiter. Loeb and his colleagues have calculated that the combined probability of approaching all 3 of these planets so closely is just 0.0005%. But there's more. The point of closest approach to the Sun, the perihelion, will occur on October 29, 2025, when the Earth will be on the opposite side of our star. This means that at the most critical time for observations, when we should see any changes in the object, we will be completely blinded by the sun. From the perspective of a hypothetical alien observer, this alignment would offer the perfect moment to perform propulsive maneuvers unnoticed, what Loeb calls a reverse solar Oberth maneuver. How do we interpret these anomalies? The scientific community is divided. Although the majority leans toward natural explanations, the conservative interpretation holds that 3I Atlas is probably a comet whose activity is not yet visible at this distance. The spectral lines could be obscured by dust or be too weak for our current instruments. As it gets closer to the sun, we should begin to see signs of sublimation and coma formation. According to Loeb, however, if future observations do not reveal cometary activity, we might be facing a 20-kilometer solid object, which is statistically improbable as natural interstellar debris. Loeb goes so far as to hypothesize that it could be a technological probe, possibly with exploratory intentions, or, following the dark forest theory of the Fermi paradox, potentially hostile. The dark forest theory by Chinese physicist Liu Cixin offers a chilling explanation for cosmic silence. According to this hypothesis, every intelligent civilization remains hidden out of fear of being discovered and destroyed by more advanced civilizations. If Oumuamua truly was an alien probe, its passage through our solar system might have been a test, an assessment of our technological capabilities and developmental level. Our inability to intercept it may have transmitted a precise message. Loeb's article also explores the possibility that the object could be a multi-layered spherical graphene solar sail, with a surface mass density compatible with technologies that humanity itself is developing. 3I Atlas remains an enigma. Its anomalies are real and documented, but their interpretations range from conventional science to the most speculative hypotheses. In the coming months, we will have more observation opportunities, especially with the Hubble and James Webb Space Telescopes. If the object begins to show cometary activity, many questions will be answered. If it remains silent, however, the questions will multiply. As Loeb himself points out, their article is largely a pedagogical exercise, a way to scientifically explore even the most remote possibilities. But it is precisely this approach that might best prepare us for the day when an interstellar object is no longer just an exercise. What do you think of 3I Atlas? A late comet or something more mysterious? Share your opinion in the comments below. If you like this video, give it a like and share it with those who are as passionate about astronomy as you are. See you in the next video.